Alright, the bits are flowing. Can you feel the bits? My computer's new heatsink is sure feeling the bits. But you're not here for that. I think you're probably here for the cat. I think that's usually the case. There he is. Hanging out, doing cat stuff. Anyway, welcome back to the stream, folks. So, we've been spending a lot of time lately on this this robotic camera, actually, and so you can't really see it doing that much, but actually I can manually pan it over, and you can at least see it move. We've actually so far got the gimbal moving around and tracking Tuco, and it's using a combination of a neural network that can detect objects and where they are, with a tracking algorithm that just detects where the rectangles are moving around. And so we've been working on this a lot. This stream will not necessarily be about the cat robot, although we'll be using it during the stream. On this stream, you know, this will be another kind of shortish evening stream, but I have this actually pretty giant box that arrived a couple days ago with some donated gear, and I'd love to do a little unboxing and hopefully some teardown of that stuff. So that should be exciting for everyone. Right now, Tuco's over here out of view of the camera because he wants to play Bolt. He brought me a Bolt. Of course, I can't find it. He always leaves it somewhere I can't find. Oh, here's one. Oh, now he doesn't know where it went. Hey, Tuke. Was that a bad throw? Alright. So, I think we're all looking forward to this, this thing actually being able to zoom around. Just for reference, you can see some of the debug output that we've been dealing with. There's the little web interface. It has status from the gimbal. That's pretty dense right now. There's a lot of good stuff here. Good results from the computer vision too. Oh yeah, we haven't really looked at the correlation tracker quality metrics since getting this graphed. Oh, Tuco's back over here where the camera can't see him. You know, I could also try carrying the flyer. One change that I made just today actually was I got the leash attached to the ceiling. It doesn't have the bungee that it needs to spring back to the ceiling yet, but it has at least an attachment up there. I installed that 3D printed bracket we made a while ago. Anyway, this thing is fun. It's a fun distraction. Can we find Tuco? Oh, he's in the kitchen. I can hear him eating. I think he's behind the hammock in this photo. It has actually gotten a little hard to aim the correlation tracker manually because of the spring back to center. The combination of that and hysteresis means it's actually really hard to do small aiming motions. So that might be something to fix. Because right now I push it and there's actually a timeout where the manual control is still active. And during that time, it's sprung back past the hysteresis. So that's not optimal. Of course, I can just hold it down a little longer, but it's actually at its end stop right there. I can swing around to the other side. There we go. So the cat sprites there are indicating the computer vision rectangle in a way that's a little bit less jittery. Oh, as Len illustrates with emoji, that's great. Anyway, I just realized I don't have a beverage, so I'm gonna go grab a cup of tea, and oh, I guess the robot likes my shoe for some reason. I can hear Tuco over here. Oh man, yeah, the aiming is a little twitchy. We could spend this entire stream tweaking the parameters here, but I'd rather do what it says on the tin and do that unboxing. You can hang out here with the graphs and the robot camera. I'll be right back. Tuco's looking for food. Oh well. Tuco's looking for some food. He's already had dinner. Yeah, the camera wants to follow. Alright. I've got some fun numbers here. Yeah, the correlation tracker has a lot to lock onto in that rectangle. You can watch that change as I move this around the scene. Areas with more texture, or at least more reliable texture at the resolution this camera is sampling at, should give me higher quality metrics. Gimbal's getting buzzy up there. I should turn the upper limit down. So this is around 200. Oh. Actually, that problem region wasn't quite at the top. We'll need to spend some time debugging that buzzing gimbal problem. Anyway. Oh, this is an earlier version of the website, so it's actually not treating this. It should be showing me two separate sliders. Instead, I've got one slider, which is designed for floating point, attached to something in the data model that's actually a vector. So it's displaying the vector. And if I change this, I don't think it'll work. I think it'll just throw an exception if I change that. That's funny. Okay. Anyway, let's put this aside for a sec and put on the desk camera. After making a cursory attempt to locate the cat. Oh, is he over there? I thought I saw him, but I guess not. Oh well. He'll come around at some point. And best of all, the computer is no longer melting. It's been staying around 70°C since upgrading the cooling, which has been great. So, yeah, Fred says the camera needs a friend camera to help. Yeah, that is one of the plans that we could have is, I mean, I do have an overhead camera in the shop here. Let's see. It's a little laggy. I still have the rectangles in their old locations. But yeah, I don't know if you can actually see Tuco. Well, so you can see the flyer there. And you can see its wire running up to a ceiling anchor. But I don't see Tuco from there either. Is Tuco under the desk? No. He might be upstairs. There are a bunch of places he could be. I mean, a lot of people have been asking about locating Tuco since, you know, this has been a problem, clearly. But one other thing that'll be true when I'm not messing with the camera the entire time is that the tracking rectangle should give some indication of where we lost him. So that might help. I mean, I think at some point there's going to have to be a human in the loop, but we want to give the human as much data as possible. But I mean, as you'll see, this is a problem in person too. Like, I often don't know where Tuco is. This just is like a normal cat thing. So, oh well. Speaking of normal cat things, every cat's got a bot Xbox controller, right? Let's actually give this a fresh card. Oh, do I not have a fresh card? Is this one fresh enough? Oh yeah, this just has like a test recording in it. Let's format it anyway, because I format it every time. Is it T yet? Oh, it found the cat. Oh, you can't actually quite see it. Well, if Tuco's gonna hang out over here, I could bring the camera out over here. But I have no idea where he wants to go right now. That rack of equipment, or not equipment, but like that storage rack is a little bit inconvenient right now. Oh, Fred asks, could you run Tuco Finder on both camera streams simultaneously without your computer melting? Unlikely. I mean, I could definitely do that at a lower frame rate. But I also, I think we would need an algorithm that is better tailored for the specific application in order for it to be good at detecting cats amidst a bunch of clutter at low resolutions. Because I don't think the current network is even really particularly good at that. And like just running YOLO to detect Tuco on low-res photos is not going to work very well or be a really good use of the resource. Huh. And it says run it on the other when the first one loses Tuco. I mean, yeah, maybe you could switch it over. You would need some delay on that because just normally it's actually losing him a lot just intermittently, which is why the object tracker helps to smooth that out. Can I help it around? Oh, we're at the end stop again. He always finds a way to the end stop, of course. That's another reason it'll be nice once this thing can move itself around. Len asks, what speed / FPS are the detection and tracking running at now? We can take a look. It's pretty close to the camera's 30 frames a second. The tracking is definitely running at 30 frames a second. The detection is maybe skipping some frames, but close to 30 frames. So this is in milliseconds. You can see the most this has taken is 22 milliseconds. And so like you can see it jitters around a lot, but you've got upper and lower bounds for the amount of time that the detectors take. So the correlation tracker is taking between 12.8 and 22.2 milliseconds, and the object detector is between 35.6 and 49.7 milliseconds. So the object detector is going to be effectively missing a lot of frames at this point. It does have a queue of frames, so it's not like you run it and then it just has to wait for the entire next frame, so it's not like it goes all the way down to 15 frames a second, but it does look like it's running at less than 30 frames a second right now. And I'm not using 100% of the GPU, so this is probably just due to scheduling or just other like synchronization level sorts of inefficiencies in the system. Yeah, maybe. So Len's asking, so this could probably run a bit slower in slow work, I think. I mean, maybe, but like the other thing is you're starting to ask detailed performance questions about a very heavily loaded system. So you're going to start to get both noisier and less accurate answers if you start venturing into that territory. So the goal here is to preserve as much performance headroom as possible. YOLO is basically my metric for how much I want to spend on the CPU or on the GPU and CPU for detection at most. So maybe we train a different network that's a similar size, but it's not like I want to be like, oh yeah, YOLO works, let's have 2 YOLOs. I don't want to go there like that. This is like the mark I'm placing at the moment, since I don't think I can afford to use like 100% of the CPU's resources and GPU's resources on this when this computer has so much other work to do. If I split this robot into multiple computers, then sure, that would definitely be possible. It's just that right now I'm doing a lot of work on one machine, and so it's a beefy machine, and like my approach to doing this was like, let's build one really beefy machine, and that'll take less rack space and probably be less expensive than 2 kind of beefy machines. And so that's what I've been doing. But yeah, if your goal was just all-out performance, then sure, like you could segment this across as many separate computers as you wanted. I mean, you can just split the SDI video signal and have several capture cards process it in parallel and do that all on separate computers. And then all the separate OBS instances could just have little checkboxes indicating which object detectors run on this machine. And then all the object detectors just send their results back to the same Rust process. So it would be very easy to just like have an entire data center crunching on this if that's exactly what you wanted to do with that much power. As it is, it fits into 4U and a few hundred watts. You get such interesting waveforms as a result of the combination of the vision system noise and all the motion noise from the system. Chris says they can't think of a better use for that much power. Yeah, I'm sure there are plenty of worse uses, like, you know, what most data centers do, probably. It's like, oh, you can host shady SEO websites and mine Bitcoin, or you could track cats. Is Tuco trying to find stuff in the cupboards now? Well, maybe I'll at least bring the camera back over here so if Tuco joins me, I can see him. Cool if I had a robot to move this for me. Ow. Where are you going, Tuco? Oh man, yeah, this will be a lot better once it's on 4 wires instead of 1, and there's a robot moving it around instead of my clumsy butt. Oh, look at my mess pile. Yeah, I need to organize that stuff too. Of course, that's the end stop. Let me rotate it physically. Somewhere I had a bungee cord I was using to physically rotate the gimbal. Maybe Velcro will do the job. No, I kind of need a bungee cord. I'll be right back. Here it is. Alright. I still don't think, I think that it's too close to the area Tuco walks through for it to track him as he walks from there to here, so we're still going to lose him, but... just like that. Oh well. Oh, there he is. Okay, anyway, maybe we can use this camera to film what's inside this box before we get it on the table, at least. Mike's Radio Repair suggests an RFID tracking tag on Tuco. Well, he's got one of those implanted tags, although I really would not want to subject him to the sort of RF you'd need to read that from across the room. Pragma on YouTube chat says maybe the object tracker can be used to detect when the correlation tracker starts to adapt to something that's not a cat. Well, that's kind of what it's been trying to do. That's its entire job. You're just watching it do the best it can. So, like, the object detector spends all of its time, every frame, trying to detect every object everywhere. That's what it does. That's just, like, that's what its architecture implements. And so if it sees a cat or any of the other objects that are on its list to snap the rectangle to, then it's just going to do that, and we're just going to pick the highest probability of those objects. But if we're relying on the tracking, then that just means that none of the matching objects are there. So it's trying its best, just can't quite. Oh, that's a great question. Electron Ash in YouTube chat asks, does the gimbal control via mouse also work via the OBS window? It doesn't currently, but we could implement that. There are messages the plugin gets for the mouse control, and I could add another message type for like a mouse input, and that could just set the rectangle location. So that wouldn't be too hard to implement. I just haven't done that yet because usually I won't be interacting directly with the OBS window that much, I would think. The idea behind the controller is it's something I can easily walk around with, and it has a nice interface. Oops, I didn't really intend for that. Tuco's actually under here next to my foot. I don't know if you can see him. He's like right there. He's really soft. So this is something I can walk around with even when I'm like directly controlling the robots. Same with the web interface, like I can easily get that on my phone and I can just interact with that while I'm physically near the robots. Whereas this is something I have to activate with next to the computer. So like the poking at OBS experience is kind of fun as a spectator, but for the spectator experience, my focus would be on making that work well at the other end of the stream. So this would be nice, and especially if I want the stream. I mean, it's a great idea for a feature, and it's definitely something that I'll implement. But yeah, my focus so far has been on the other tools because they're multi-purpose, whereas the OBS tool, I'm kind of only going to be interacting directly with it if I'm like in the middle of running a stream and I want to move the rectangle around or do something else like that. You can see these little blips as the integrated gain builds up, just briefly. It's kind of fun. And these are all very small, so the output is also dithered. So any, it basically adds plus or minus 0.5 of random noise to the rate control signal, so that you get a little bit more resolution. Otherwise, it would tend to round things to one or another integer, and especially for very subtle motions like the what is it called? The drift compensation. You want to be able to move very slowly. So, for example, this control should probably be the other way around, but you can see here, this gives me a very fine control to null out the drift in that axis. The manual control is not the best because it does, the drift compensation itself needs some drift compensation, so I plan to have some closed loop feedback for that. The plan there is probably just a very slow proportional loop that controls this based on the, well, integrated, I guess, but a slow control loop that controls this based on the averaged out velocity of the tracked rectangle. Oh yeah, so Len's suggesting some object tracking fallbacks. Yeah, that would be great. One thing to do there is, right now the object tracking results are not like stable in any sense. They're just sort of flickery apparitions of what the neural network is hallucinating on every single frame. So if you want to have some kind of fallback that isn't just always reporting all of the choices because it's always noisy, then it'll need some kind of lockout, like if I haven't detected an object that's at least this good in this amount of time, then start looking for this category of objects. Oh, and then Fred suggests Sucoflyer should have a small plastic bolt launcher. We're definitely going to have some automated bolt launchers around here as a future step in this project. They just probably won't be on the flyer. I think the right thing to do there is to have them be kind of at ground level so that they send the bolt kind of skittering across the floor. Because that's what he seems to like, and that's also easier than building the launcher into the flyer. Anyway. The questions are cool. I'll keep answering them, but I'll also start opening this if there isn't anything else to answer. Oh yeah, the controller is really helpful. And this is wired to do a bunch of other things. Like I've got a couple of different ways to quickly turn it off. Like there's an on-off. There are separate buttons for on and off for the gimbal, so I can just quickly turn off the gimbal if I need to. There's also halt mode, which will tell the winches to stop immediately. And for the gimbal, it will start sending, as you can see, it doesn't completely null out the rates, but so drift compensation still works in halt mode. Otherwise, halt mode will not be very stationary, but it basically just tries to keep the gimbal as stationary as it knows how to do without listening to the computer vision. So sending some zeros plus the drift compensation plus the dithering. As you might have also noticed, the CV wasn't updating, so. Oh, Tuco's getting ahead of us. Cool. Hey, Tuco. Oh, you're so comfortable, Tuco. Alright, so this giant box of goodies comes from Umar Sear. I appreciate this a lot. I hope we put these goodies to some good use. Looks like Tuco is camping out on top of the box preemptively. And I mean, I could take him off, but he's just so enjoying this. Yeah, with the Xbox controller, I've got some buttons that are helpful. I'm not using the D-pad for anything yet, but I'm using one of the analog sticks for moving around the object tracker, and one of them for controlling the winches. And then I'm using the left and right triggers as a Z-axis for one of the analog sticks for moving the robot up and down. Hey, Tuke. I should really be using this new table, which is low enough that my tea can't spill on any electronics that aren't on the floor. Hey, Tuke, how do you feel like going on my lap? Oh my gosh, he is so comfortable right now. He just like made the best noise at me, and he's like staring in my eyes like he just loves this. Aww. Oh my gosh, Tuco, you're so in a good mood. And you're just like keeping your paws tidy, rubbing your face in my hand. Oh, this is a great way to start a teardown. I can barely read the YouTube chat from here, but it looks like Mike's Radio Repair just said, I think someone wants a new empty box to play with. Yeah. Alright, Tuke, can I put you in my lap, honey? Whoa. I know, you're just gonna go elsewhere. Let's try this for a sec. I just wanna know if you'll like it. No, you just wanna go elsewhere. That's cool. He's got plans. Alright, well we've got this, and he'll have the box later. Wow, so there's a lot going on in here. So the most obvious object here is actually this heavy contraption. And this, you know, I have to say this looks like something that might be useful in a Tuco Flyer sort of project. So let's take a look at this really quick and then see what else is in the box. Oh yeah, SFMC says Tuco seems to have somewhat pronounced thumbs. Must be a highly evolved cat. Yeah, Tuco's polydactyl. He's got a lot of thumbs for a cat. Yeah, so this is some Cisco video conferencing gear that was donated. And yeah, this seems pretty interesting. I mean, I have no idea how proprietary this stuff is or how documented. So I don't know whether it's whether it's a matter of just finding the right manuals, or whether there might be reverse engineering, or even if any of this stuff works. But there's definitely some possibility here, and this looks like a really nice pan-tilt zoom camera. So there's some tape here, keeping it in position. Like get that out of the way. My desk could use some tidying. This is going to take so much desk space. Ooh, Fred says, I think they can take serial commands. That would be great. Whoa. It looks like the back is open. Yeah, what is the model number, just for everyone playing along at home here? Alright, Tandberg Precision HD 1080p, designed in Norway, made in Norway. Wow. 12 volts at 2 amps. Let's make sure that we're as servo AF as possible. Yeah, this is a lovely device. So we have HDMI, SDI. That's great because I like SDI. I use a lot of SDI around here. And then we have something over RJ45. It looks like that might be Ethernet. This has got a little plug on it, but it says Amphenol RJ45. And then the socket has lights like it might be Ethernet. The one over here does not have lights, so maybe that one is serial. Yeah, that says camera control, so that's likely the serial over RJ45. And then daisy chain, which might be some other kind of serial, over a, what is that one called? RJ11? So yeah, wow. Let's get that tape off there. Whoa, hey Took, you're such a jumper.
Alright,
so as far as condition, I don't really know much about this. Looks like the back cover is loose. And there's a big heatsink back here. We'll take a look at that in a sec. Actually, maybe it's easy to get that in now. So here, polycarbonate ABS. Pretty decent plastic. And then, zinc. Is that what that means? Oh, this is a really fascinating thing. So that's actually just a surface mount connector underneath. That's not actually attached to the metal. I don't know whether this is just structural or also thermal, but something this big and chunky, I've got to imagine it's probably at least partially thermal. And there's a big old flex going down through the arm to the base of the camera. Can already start to see some ICs under there. Something with a Fairchild logo. And then that goes, those both go to something else inside the camera. And I was just starting to feel this rotate a little. Ooh, Fred says, I believe that's got a 12x zoom. That would be nice. Oh yeah, this could be really wonderful to shop far away kind of camera if it works, or if we can get it working. Oh yeah. That's really smooth. Oh, this isn't continuous, is it? No, so it has an end stop right there. And an end stop right there. So it has a little over 180 degrees of rotation. You know, I think I saw one of these at a former employer's office. They mount on top of a television and then they can kind of scan the conference room. So this is actually the business end. This is what you would see in the fancy corporate conference room environment. So you'd have this Oculus kind of zooming in at you from above the television. It feels like a stepper motor driving this. Hey, Took. Oh yeah, and so this axis wants to move on its own too, and this feels like a stepper. I think Tuco knows that heater's off. You can still hear the pilot lights, but it's not really warm. Well, So I think we should try to figure out how to tear into this, but maybe let's see what else is in the box first. I also don't know if this will stay on under some configuration. There is at least a little bit of a broken plastic tab on this, but I'm not sure if it's a relevant structural one. Alright, well we can fuss with that later. It's quite possible there's something else not quite fully assembled there. Kerplunk. Oh man, that is a bit of a beast. There's got to be some glass and metal in this device. Ooh, Fred's already found the serial control documentation. That's great. Mike's Radio Repair says that's what they make duct tape for. I agree. There's also hot glue. Oh, a Tuco. The camera's actually got a great idea of where Tuco is. It's just not actually keeping him right in the center of the frame because I've told it not to. I've tried to give it some room to move him up and down in the frame as he moves. So maybe I'll just change that so that that does keep him more centered. Pitch gain region width. Like that. That may cause it to jitter in other circumstances, but it's helping right now. We'll see how well that serves. Alright, so... I think the composition of this box is that there is one enormous thing, and then a lot of little things. So let's take the enormous thing out. Oh yeah, this must be the box that controls it all, the set-top box. Yep. Has the same logo. I guess Tandberg must be somebody who like resells this gear, or did they actually design this? I don't know. I don't know what the vintage of this is, but I've seen this stuff with Cisco nameplates on it too. But maybe this is the OEM, and then Cisco rebrands it, or the other way around. So we got 4 big old fans in the front. Let's see how much of this I can get on the desk. And put away the foam before Tuco starts chewing on it. Okay. Oh, there's a lot of connectorage on the back, so I'm going to carefully hold it up for a sec. Oh yeah. That is a beast. Alright, Tuk, can I put this down right where you are? Maybe. Excuse me. Thank you. Oh, wow. So, yeah. Let me show you the front and back of this thing before we move on, and we will definitely be peeking inside on this stream. So, what does that say? Power, call, IR, and alarm. Normal teleconferencing set-top box kind of stuff. And here we've got 4 of these little blower fans. And got a little nameplate on the bottom. Oh, this is awkward to hold. Wow, 2.8 amps at 110 to 100 to 240, so universal power supply. Got some FCC stuff, but I'm gonna put this down because it's heavy. And I guess we can just look at the back now, because the front is flat. Whew, Codec C90. Oh man. Wow. So this is this whole section So we've got video inputs, we've got audio inputs and outputs. This whole section on the left that I'm not even showing you, can we zoom out a little? Oh, wow. Look at all that DVI, too. And GPIO at 12 volts. Both kinds of USB. All two kinds. Those are the only kinds we have. And yeah, the XLRs are pretty great. Wow. So this has built-in microphone amplifiers. It's amazing that they supported so many video standards. Oh, geez. Len says my theory is Tuco stepped on an upturned dip once. That's why he's careful. Yeah, man, he's very careful. You know, the most painful thing that I think he's had to deal with on his paw, as far as I know, is he had an ingrown nail once that I had to help him with. But this thing also looks really nice with the connectors catching the light up there. Bunny says, I bet there are some expensive components in there. Yeah, tell me about it. This is amazing. So where are the... Oh, okay, so the color code up here is the white on black is input and black on white is output. So T-Link is, I guess, something that goes over RJ45 and has an input and an output polarity. So that might be some other serial thing, or like RS485 or something. Two Ethernet ports, which don't seem to be distinguished from each other. And then we have all the directional audio inputs and outputs. The microphones are inputs, of course. Line out over XLR, so you just plug this directly into some really nice studio monitors over XLR. And then these are all the video outputs. So we have effectively 2 usable video outputs, and then some legacy stuff. Wow. Oh, that's great. So yeah, Fred has some docs from Cisco. So I guess this is... Oh, okay. And then reading up a little bit, Nick says Cisco acquired this company, Tandberg. So they're sort of the OEM. And the acquisition happened in 2010, so interesting. The stuff I would have seen at a former employer probably would have been predating that, but it might have been some competitor to this stuff that just looked very similar. Wow, this is great. All right, let's see what else we have in this big box of goodies and then take this stuff apart. Oh, yeah. So we have surface mount components. Oh, yeah, wow, okay. So I'm all set on 97.6K resistors. I will never need 800K resistor unless I need a different size. What size is this? 0402? Wow, I really don't know how to read this. I don't see the package anywhere on there, but you know, I have a ruler for this sort of situation. Well, I think I have a bunch. These were the 2 that were within easiest reach. I have one from Octopart. This is actually something that Star Simpson designed, and she was telling me about how it was, or just like the process. I don't know. It took a lot of going back and forth with the board house to get this many colors. But this does have passives. Cool. And I've also got one from Digilant, which I think works as a PMOD with capacitive touch. That's kind of a cute set of features. Oh, are we not? Oh, wow, this is really confusing the servo AF. This doesn't actually have resistors, though. This is just a prototyping area. I think these are 0402s. They look too big for 0201s, for sure. Ah, none of that is in focus. Yeah, I think those are 0402s. Alright. This is 60K and this is 97K. Cool. Those might come in handy. I don't have a lot of stock of just like tiny resistors, so it's actually good to have a couple of values, like a big stash of a couple of values. And I mean, this is probably more than I will ever need, but it is certainly better than having 0. And resistors are cheap, so I appreciate that. That's great. We got some padding. Pop this before Tuco does. Oh man, the robot found the shark hat again. Oh, Crestron, that name sounds familiar. I wonder if those are the ones my former employer had. I've seen these high-end pieces of gear in a couple places. Like I think when I worked at VMware, they had these in some conference rooms, but I don't remember which model those were. They might have been Cisco, but I think my college had some too. They had some new part of the engineering building that I briefly worked in, and oh, I don't know why I just opened this or started to open it. I was just absent-mindedly like I was opening the air bubble packages, and anyway. I tend to absent-mindedly take plastic off of things because Tuco devours plastic, but in this case the plastic is, I don't know, I mean it's not like these need anti-static protection, but at least it's keeping them organized. So 54K and 33K. These are low 4H. Oh, this is bigger. This is, what size is this? I think this is a 603. That's cool. So I have a 603 33Ks. These will be handy. I'll have to figure out a good storage solution for my surface mounts because I have so many different kinds of surface mount things now. I've got like little DigiKey packages. I've got like a couple of books of little strips. And now I've got a few resistor reels. I've got some like semiconductor reels. Ooh, and yeah, I've got also some like random strips like this. Right now my storage is very inelegant for this sort of thing. Ooh, what value is this? Is this 25 megahertz? These are crystals. Oh, 20. Oh, they're numbered. Wow, not on. Okay, wow. So these are actually two strips taped together. Let me reset this camera. Oh, yeah, that's a good question from Robert, who says, I assume this is a different overloaded use of AES that isn't advanced encryption standard. Yeah, in this case, it's it's digital audio. It's basically SPDIF, but with a different connector and different physical layer. Oh man, these are already falling out. I should probably try to get these into my crystal repository, but since one has fallen out, I can't quite tell which of these is the frequency, but I'm guessing they're 25 megahertz. Let me show you under some magnification, which is probably a microscope. So yeah, we've got a bunch of these. I'm guessing these are 25 megahertz, but I'd probably have to look that up to be sure. The They're probably not 42 megahertz. They might be 10. Yeah, I don't know. Anyway, that could be handy. Crystals are always useful. Got some more, are these capacitors? Oh, that's, whoa, 0603 2.2 microfarad. That's a very useful combination. We'll definitely get some use out of those. What's the, they're not like Y temperature coefficient, are they? I think I recognize this part number. Because I've ordered Murata capacitors before. That GRM prefix looks familiar, but maybe that's pretty wide. Anyway, assuming these don't have a terrible temperature coefficient, they're really useful. You've got to watch out with ceramic high-value surface mount capacitors with low voltages, but these are rated at 16 volts though, so for like 3 volts, it's probably pretty good. And this is an empty bag of inductors. These might have fallen out. Wow, there's a lot of surface mount goodies here. I will definitely need to find a way to organize this stuff. Whoa, are these 0201s? I think these are 0201s. This is 16 ohms? Really? 16 ohms in 0201? What is that used for? Huh. Termination resistor for something, I don't know. Yeah, I don't know, that's a little puzzling. I don't know what you would use such a low value in also such a low power handling sort of package. I mean, of course, there are all sorts of uses for resistors where you're passing low current, but it's just like 16 ohms is a strange value to begin with. So that's interesting. Maybe like a current set resistor for a system on chip or something with transceivers. Interesting. What are these? 931 ohms. Cool. So just more resistors. That's cool. Alright, more resistors. I will have to go through these in detail later. I don't want to bore you all with like 800 identical packages. Oh, here's some more ceramic kind of high value 0603s. More resistors. 91 ohms again. That is so weird. Whoa, are these, whoa, tantalums. Whoa. Whoa, that's, ooh, that's nice. Yeah. What are these? I'm gonna have to read the top of the capacitor instead of the, because of course they give you the part number, but if you don't know the encoding scheme, you can't just like read the values out of there. Like that might be 4.77 microfarads at, I don't know, 10 volts or something, but it does look like they're probably 4.7. Anyway, I don't want to open this right now, but it seems like that's likely. So this is actually quite nice. It could be quite useful. Whoa. Whoa, we got some good inductors. Ooh, I could come up with some good uses for these probably. Yeah, Hal says it's like a shopping haul, yeah, basically. So, oh, these are nice. Big old power supply inductors. What are the values on this? This is probably what fell out of this bag, if I had to guess. This says power inductor unshielded 47 microhenries. 173 NL. I don't know if these are the same ones, actually. I'm gonna leave them out of the bag if I'm not sure. Got some semiconductors. Let's go to the microscope. Oh, interesting. JD says speaker emulation. Are you serious? I don't think you're serious. Not in that tiny of a resistor. Oh, what are these? LVT04 BE62701 U lowercase n 60736A. Yeah, I mean, I'd have to Google it. I don't have any idea what these would be off the top of my head. My first guess based on the labeling would be something like either a logic or a MOSFET, but it's got way too many pins for a transistor package unless it's a bunch of transistors, but it seems unlikely. More resistors, 45.3K. Whoa, we got rice. Actually, I think it's diodes. Oh, okay, Ryan. Oh, okay. 74 LVT04. Oh, yeah. LVT04. I, for some reason, wasn't recognizing that as a logic family. It seemed vaguely logic family-ish, but... Oh, yeah. But none of the other numbers make any sense. But okay, if these are surface mount hex inverters, that is a super useful part to have around. Oh, okay, and then Chris says that's NX peak style lettering. Okay, I'll try to file that away. That is a little weird, but cool. So these are logic hex inverters, useful for a great many things, like making oscillators and very simple pulse shaping filters, and just driving current, and making power on power off circuits, and all sorts of things. So great little devices. Could probably make musical instruments, all sorts of them, just based on this chip. I really should find another box that I can put these in, as I take them out of the giant box. Camera's having a good time with that shark hat. Oh, and now it wants something else. Now it wants to oscillate. Cool. I think that's the limiter gain being set too high. No, that's not the limiter gain. That is the plain old pitch gain region. Is it? No, that's got to be the limiter. What? It's still happening even if I turn the limiter gain all the way down. Huh. Oh, it gets buzzy if it goes all the way That's like 490-ish. Oh yeah, now the limiter's just not working. Okay, that's better. I don't know what was causing that oscillation. It seemed like I could break the cycle by manual control of the computer vision, but that doesn't really tell me what was causing it. Oh, nice. Chris was just reading off the specs for that 74 LVT. 32 milliamps max output current and 16 ohms output impedance. Yeah. 16 ohms, I wonder if that's a coincidence. Yeah, that would explain all the little 16 ohm resistors. If that was the output impedance, that might make a good termination resistor. Oh man, this cardboard box will hold all the reels just right. Alright, so what else do we got? Yeah, now it's actually tracking me. Kinda. Alright, we got a little anti-stat box here. Whoa! STD-P432, or, sorry, I can read numbers, right? STD-P4320 from ST. This is some kind of application processor type thing in VGA. Man, with the people sending me BGA stuff, I guess I'm going to have to start making some BGA boards. Yeah, wow. Anybody who's faster on Google than I am want to look this up? I'm pretty curious what this is. So we've got a handful of those, which we'll try to de-overlap. And 3 of these little 8-pin buggers, which have paint dots like they're programmed. I'm going to put this whole thing under the microscope in a sec. I'm just de-overlapping them. Oh, a Displayport splitter demultiplexer. Wow. That is much more specialized than I would have expected. But wow. Hence the DP, Displayport. And then we have these little guys which look like EEPROMs. So these might be EEPROMs programmed with settings or firmware for these chips. Wow, that's a strange little collection of chips to have. 25P40VP. Is that 40 kilobits? Ow. So that could be really interesting as just like if we wanted to experiment with anything related to the Displayport protocol and just needed a bunch of transceivers for something. That could be really interesting. And we got, as you can maybe see, here's our grains of black rice here, or diodes. Are these Schottky? Manufacturer part number MC20R82M. This doesn't even say they're diodes, they just look like diodes. Maybe they're capacitors. Actually, I don't see a stripe. They say R82 on the top. Yeah, these are a little weird. They don't, like, if it was a diode or a capacitor, they would have a stripe. And let's take this out of the outer bag. I think the inner bag has more information. So I'm assuming MPN is manufacturer part number. That's MC20R82M. Yeah, I don't know what these would be without Googling them. It says R82 there. I'm curious about this. I'm gonna check that really quick. Unless somebody else beats me to it. MC20. Oh, it's an inductor. Oh. Okay. Cool. That's nice. I like inductors. I didn't used to like inductors. I had sort of a irrational vengeance. But they're nice. I like inductors these days. Alright, these are the capacitors we were seeing earlier, the 0603 2.2 and 4.7 mic. Cool. A little bit left in there. We have 1.6K 0805 resistors. We have half watt, 0.025 ohm, 2010 surface mount resistors. So these are like big old wide things you would use for a current shunt. See that? That's really nice. These would make very nice current shunts for voltage glitching and stuff like that. And 0.025 ohms. So that's super useful. I will definitely get some use out of these. Oh man, a couple more reels of tantalums it looks like. These are pretty nice. What is this? Yeah, 100 microfarads, 16 volts. Whoa. 10%. Those are useful. Yeah, no, I'll get a lot of use out of these because I did not have a good supply of just tantalum or just like any bulk surface mount capacitance. So like when I'm just making boards for my own use, this seems like it'll fulfill that need quite nicely. And then more tantalums. What are these? I think these are more 4.77. This seems to be the same part number as that other batch, and they're still not labeled very well, but I think that's 4.77 mic, 10 volts. Let's put that back in the anti-stat bag at least. There are still a few more odds and ends in here. And Tuco is going to get this empty box real soon. Whoa, it's a tiny chip. There's some tiny chips hanging out. This is great. It's basically like a delightful little surface mount junk bin has been emptied into this package, and I get to pick through it, and it's fun. Here's a little loose tantalum from that other bin. I'll give it back to its buddies. Alright, I think we don't have any parts left. Hey Took, you want this? I'll just leave that on the side in case he wants to hang out in it. Alright, we have some more resistors. 1 ohm, nice. This is also probably pretty handy. These are 0603 1 ohm. Another handy little shunt. These look weird. Oh, these are resistor networks. .24 ohm, 5%, 4 resistors. Nice. Some more resistors that you would use for impedance matching, termination, that kind of stuff probably. It's one package with 4 resistors side by side. These are really common. Um, 1/16 watt, 5K. What package is this? 0402. Yeah, more resistors. And now we are down to some semiconductors. Look at that. I think all these are going to end up under the microscope. ISP 1507. Not sure what this would be. Looks like an LCC or maybe a VGA package, something without visible leads. Oh, and it seems to have a thermal pad on the bottom. Another little one. This looks like it's been used. ADB and AW with a plus. Ha! Robert says you should put one of each into some acid and decap them. Yeah, I don't have any suitable acid around here at the moment, but that would be a cool thing to do. I do have a lot of chips around here I could decap if that was a thing I was doing. Yeah, I don't know what this one is either. Maybe one of you feel like looking it up. Here's one with an Intel logo. Oh, is this just flash? I think this is probably flash memory. .256P30TF. Nick has had good luck decapping chips with a 75-watt laser. That sounds good too. Fred says, sounds like a well-connected chemist should sponsor the next mailbag. Yeah, that's an option. I mean, I also don't have a fume hood around here, which would also be handy. Oh, is this more Displayport stuff? DP139 from TI? Interesting. This is quite possibly more display transceiver stuff. Oh, Robert suggesting doing with sulfuric acid drain cleaner. Yeah, I guess I could go that route. How well does that actually work? And I mean, that doesn't solve the need for having a fume hood, so I'd probably just have to do that outdoors or something and figure out how to do it safely. Okay, cool. Fred reports this is a Displayport to TMDS transceiver. Alright, one last thing. We have this little bin of parts here. Whoops, I've lost them already. Oh, are these just these two? Are these going to be more programmed memory chips? Looks like it. Interesting. Little paint dots. I would assume these would have settings or firmware that go with those other chips, but we could take a little side journey and actually try to read these. Oh yeah, these are Spansion. FL24KIF. Let's turn that around. Yeah, it looks like we've got some programmed memory here. Interesting. Well, that's all the surface mount parts. I think at this point it's time to put the surface mount goodies aside and dig into some of this big hardware. Well, thanks so much for all this wonderful stuff, Umar. I am going to get plenty of use out of at least some of these surface mount components, and the rest I will at least figure out how to organize. Got a good brushed metal texture going on here. Ooh, 4 megabit serial flash, according to Ryan. Thank you. Draven asks if the package came with a letter explaining the contents. It did not come with a letter, although we had been communicating beforehand, so I knew what was coming. And I heard it described as some video conferencing gear and a bunch of surface mount parts, but I didn't really know the details. So, should we open this first? I think the camera might be trickier to get into, so maybe we open this thing for some satisfying ASIC porn. I also need to might move some of the light closer over here. I have the light like right above the camera now. That is not a great location for the light, but maybe that's a little better. I've certainly got a lot more on the front of this whole thing now. Alright, let's have a screw bin. Oh man, this whole thing was put together with Torx. Where's my Torx? think this will do. Oh, yeah, Chris is asking what this is. Yeah, for anyone just tuning in, this is a really expensive-looking bit of video conferencing gear. So this box is the Tandberg Codec C90. It has a bunch of video inputs and outputs, and it's designed for fancy office video conferencing scenarios. So, you know, people are doing like business role-playing, and they need to have a good network connection. It's like Skype for really rich people. This looks to be a T10 Torx. I think just this top panel comes off first with 6 screws. That appears to also be attached to the back. Or maybe I'll just break all my fingernails on it. Well, let's just take out more screws. These seem to be the next ones. So far all of these are the same, which is nice. Very nice. Oh, that's beautiful. Ryan reports this is 1080p 60 compatible with up to 5 simultaneous inputs. Nick says, it's like blank, but for really rich people is an endlessly entertaining category of thing, right? This is made of screws, and this is not sheet metal. This is a thick hunk of metal. Oh yeah, I think that was the key. And then does that hinge? Oh my god, I can see so much money already. This is great. Yeah. Oh, copper plating. Oh my god. Oh, it's okay. It's just like foil, but still, that attention to detail is wonderful. Oh, and this is welded. This has been hand welded, not very well, but somebody squirted at this with a MIG gun. Oh, cool. Yeah. These are like not good MIG welds, but somebody still did them, which is pretty interesting. So that's attaching the thick old piece of, is this non-ferrous? I assume it's non-ferrous, but yeah, it's not magnetic. So if it's aluminum, did they really MIG, or is that TIG welded? Can you MIG aluminum? I don't actually know. So somehow the aluminum, okay, are these sides? Yeah, so it's aluminum to aluminum. Can you do MIG aluminum to aluminum, or is this actually some other kind of welding? Anyway, this is pretty great. So this is the bracket that we just unbolted. I wouldn't have expected those bolts to hold it in, except this bracket is welded. So, and then on this other side, this is the interior lip, and this actually forms the nice edge that holds this bracket in on the other side, if it would ever focus. I know the camera wants to jump ahead and look at the ASICs also. So that's pretty neat. And then just, wow. 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 Actually, these transformers look kind of grody. Of course, I'm focusing on the bad, of course. Look at me, I'm just being such a negative, awful person. But that jumps out at me a little bit. Is it supposed to be like that? That looks like the goo is leaked out of the tape on this transformer a little bit. But maybe it just discolors like that. This is tape. Yeah. I think these are just the hot spots on the transformer and the tape is discolored, but whatever. Anyway, so we have a power supply. Very wide capacitor there. No obvious problems other than the weird discoloration, which may or may not even actually be a problem. All the fans along the front side. Looks like we've got kind of a circular airflow going on because there aren't really any exhausts elsewhere. Sorry about the camera angle. Oh. So, you can already see the Micronix Ethernet chip down here next to the two network ports. So we got a big nice line filter, we got the power. The power comes in over here to the bottom board. The bottom board's also running the fans, and it has the network. So that might be like a main digital board. There are 3 stacked circuit boards here. There's like a main digital board, there's the board that seems to require all the heat sinks, and then there's this board which is just microphone amplifiers, it looks like. Well, actually this is amplifiers, this is multiple purposes audio. Like this is microphone amps, this is line out. I don't know whether these microphone amps are running off the same board, because this is, if we go back to the rear inputs again. So these are a bunch of microphone amps. It's going to have presumably pretty nice low noise preamplifiers for all of these. More analog audio, video input and output, analog and digital, and then digital communications and power. So, wow, and this is just really nice. So all these chips over here are just analog video codecs. Oh, wow. Like, oh, that is really nice. So these would be the, are these all outputs or inputs or both? These are, those are all inputs. Yeah. So it has 4 SDI inputs and 2 analog, 3 analog, 2.5 analog, and then, oh no, there's the composite. So yeah, it has 3 analog and 4 digital inputs. No, 4 SDI inputs, 8 digital inputs, and 3 analog. Okay. So all of these coax on the top are analog inputs. So they're going up here to these, I think these AD9388A chips must be the incoming video receivers. So I assume that's where the A to D would be happening. These are SDI, these 4 on the bottom right, and so they're going up here. These little things I'm pretty sure are the SDI codecs, I think, or maybe that's RAM. Yeah, the little Micronix things are probably RAM, and It was just weird because I was expecting the SDI to be going into a big old BGA chip, but the SDI seems to be connected to this little SOIC. VM87AB, so maybe that's just like an outgoing video amplifier. It looks like the SDI is this combination of chips over here. Oh, cool. Chris reports that the 809388As are basically all-in-one video input chips for the analog. Okay, so these are the ones that I was originally saying something incorrect about, and now I'm pretty sure these are just RAM. But the SDI, which come in at these coax, is it all of those? It's this one, that one, and that one. So I think those each go to, no, there should be 4. 1, 2, 3, and 4. Okay, so these left 4. These right 2 are analog. Really? I think that's composite. Weird. It could just be that the placement of these components is kind of unintuitive on the board, but like these left 4 are SDI inputs, and it looks like these traces are leading from here to this SOIC chip, and my guess is that maybe these 2 chips are responsible for the SDI. The little SOIC is a VM87AB, and then the larger one next to it is a VM842AC. So those might be part of the same family. Oh, and then there's this big long one. That is a strange package. Can we get this under the microscope? Oh yeah, Len suggests now that I have a camera that can track Tuco, I need a camera that can track whatever chip I'm talking about. Yeah, maybe when maybe like a Alexa, but for chip models, I can get it to bring me data sheets, and only during streams. Alright, that's the memory-ish thing. And then there's the SMA connectors. Alright, and then you can see the input going over to this chip, which is that's a National Semi VM87AB. And then that does seem to be connected to this other one, the VM842AC, which is maybe the actual digital deserializer thing. Oh, and then that seems to be connected to this, which I'm guessing is a memory, because like, they all share these big parallel buses. I'm guessing this is like a parallel memory connected to the, like a PHY. Oh, what is that? Or maybe it's a bus transceiver of some sort. Ah, ACH244, so it's just logic? Huh, that's pretty weird. Is that just like a wide logic chip? Oh, okay, Chris is confirming that this might just be a bus transceiver logic switch kind of thing. So that might just be how these are all sharing a big, so like maybe there's like a big 8-bit or 16 bus connecting these all to the ASIC, and then this just allows them to multiplex all those input receivers together. Alright, so those are the inputs. What about the outputs? The outputs are on the bottom board, I think. So this might be set up, I mean, I'm kind of curious how they do the audio amplifiers. Well, let's just take off boards. I want to see what's under this. I'm sure a lot of you do too. So now we're back to Allen keys instead of Torx. Where did I leave those? Here they are. Over where I was doing the leash assembly earlier today. Good old lime green M2.5 wrench, maybe. Yeah, those are a bit torquey. Not very long. Is it just those two? We have a bunch of male and female pins, like the 2mm style, right on that side. Oh, it looks like all the connectors have to come off the back too. Oh, Chris says they missed the specific part number. Which part number? Were you looking for the bus transceiver, or? Oh yeah, Mike's radio repair has a few answers actually. Wow, and Jeremy Stray says MSRP when this came out was, is that $52,000? What? That's not a typo, is it? 52,000, really? And then Mike's Radio Repair says you can MIG weld aluminum. Wow, that's cool. I was not aware of that. And they also noticed Teflon coax cable. Wow, yeah, no expense spared. And then Jeremy reports 4 full-res video calls at once, up to 8 microphone inputs. Yes, $52,770 for this thing, so that rich people can Skype exactly the way they want to Skype. This board is going to fall out if I keep doing this. I think I've got a couple more screws I can do. Wow. So now I know why the company I worked for only had one of these and they didn't let me use it. Actually, I think they had a bunch. I just only ever saw one of them. Oh, and this has yet another different kind of wrench to take out the little phono plugs over there. Little phonomajigs. Is that T7? It is. Are these self-taps? Hard to tell. They're definitely going into plastic. That's probably just the standard connector they got, though. The other thing I'm noticing is I now have a geometric constraint. These RCA jacks want to go that way to get through the panel and then up, whereas this whole thing is attached with 2mm headers that want to go straight up. So I'm guessing this means I have to take the entire motherboard assembly out before I can unstack it. Pretty sure that's the case. Are there screws on the bottom? No, there are captive nuts pressed into the bottom. Cool. Huh. I don't know. Oh, maybe I have to take the back plate off. Well, because I'm thinking even if I take out everything, I then have presumably these standoffs are attached to the bottom, and I won't be able to slide it that way. Seems likely I want to try to take the back panel off. How does that work? Oh no, the back panel does not come off. That is part of the same piece of metal as the bottom. Okay. Well, wow, how does this board come out? Maybe I can just unplug it and then hinge it out. Maybe that's viable. Oh, yes, great. I didn't just like rush in and try that because I didn't want to break it, but it looks like that was fine. I'm almost entirely sure it was designed to come out that way now. Okay. So this doesn't have that much on it. Looks like the microphone amps are split up between these two boards, as you'd probably expect. Oh, that's nice. ADG 453 is the amplifier. Wow, they've got a couple of fancy looking parts on here. Oh, and well, let's get this under the microscope. There's some stuff you need to see. Let's put this aside. I could actually turn on the monitor so I can see the microscope. So, this is the assembly number and such for this particular board. So we have these T logo chips. I don't know what that is. 1510. And there's one of these per microphone channel on the top side of the board. Also got these National Semi 5532s. Another T logo chip. And then on the back side, we have some more, these are analog devices chips. ADG 453. And some little SOT23 doodads, which might be power regulators. Or voltage references. So yeah, I don't know how good these amplifiers are. We'd have to look at the data sheets and see how they're actually configured, but There are a lot of parts here. They seem like mic amplifiers. Oh, here's another chip way out over here. This one. Linear Tech 8K 3850. Looks like a linear regulator, maybe? It's kind of underneath this area. Another probably regulator over there. I mean, I'm assuming at this point probably everything on this board is either an amplifier or something for power management. We've got a switching supply up here, and then several local linear regulators, it looks like. Oh, what's that? IDT. No idea what this is either. IDT 4S or 49 FCT 3805 PYG. Alright, that's pretty interesting. Let's put this aside and go one level deeper. Oh, and I'll fix the chat, sorry. I think the camera is having some servo AF problems right now. It looked like it was kind of jittering in and out. Oh, neat. That T1510 looks like our preamp. Roger fetched the datasheet there. Low noise, high performance audio preamp, I see. Oh, interesting. N5532 would be NE5532, probably not NatSemi. My chip looks like TI. Originally from Signetics. Interesting. Alright, let's bring this box back up. Alright, and then we have this big board. Underneath the board we just removed, there's mostly power supply parts. These little parts here are almost certainly FETs. They're labeled 4641N. Right next to some nice big shunt resistors, coils, and capacitors. So I assume we'll see a switching controller on the bottom side. That is a fancy looking inductor. See that copper stripe? Is that just a single turn? Wow. Maybe the heatsink is the next thing to take off. Ryan's surprised it doesn't have redundant power supplies. Yeah, man. Those fancy business types would be pretty mad if their Skype session died. Oh, dotting. Oh, the dots on the circuit board. That's a good question. I think that that's done as a way to put down enough copper that the etching process is more even without actually making it continuously conductive. And I don't know why they don't want to just put a plane there. But it looks like for some reason they're pouring copper, avoiding turning it into a plane, but still having it take up space. And that's the extent of what I'm guessing about it. I don't actually know why they did that on this particular board. It's a pretty distinctive feature. Maybe someone out there knows the answer. course, the heatsink has some nice little conductive fingers headed over here to the edge. You think there are going to be any ASICs in here? I mean, of course there are ASICs. I meant FPGAs. There are definitely ASICs in here. Alright, how much does this want to come off? Slightly. We'll slightly tolerate coming off, maybe. Not very much, though. Looks like we're dealing with thermal pads on each chip. That might be difficult. Can I get this board off? This thing is really not easy to service. Like, I have to imagine they have some kind of giant breakout assembly for actually testing this thing. Do I have to take this out to get to the layer underneath it? I assume I do. Oh man, I've got to take out all of these also. Ugh. Alright, I guess I should photograph. I mean, we've got plenty of video footage here for this, right? But I guess I can just frame grab that to show how this goes back together. I'm about to take some cables off. Yeah, let me zoom in on that dot pattern if that's what you're talking about. Yeah, it's a little bit strange. I'm assuming it's for leveling out the amount of copper that's etched during manufacturing without actually making it contiguous, but not quite sure. And I think I just have to start unplugging things. This is really annoying. Don't design your products like this, kids. Ooh, yeah. These connectors are nice, at least. There are so many of these. And the way these are installed, it just feels really hard to service this thing without just getting right in around all the chips. And you'd have to do this to get to the bottom board at all. Doing these without damaging the coax is... I mean, I'm trying to be very gentle with all of these connectors. There we go. I'm kind of using 2 fingernails to pull it up from 2 corners. And they have this very satisfying kind of metal on metal sliding sound as they come out. Whoa, IX 5000 encoder. Which one is that? Ryan just quoted a price of $8,500. Is that like the current version of this? I sure hope this one isn't still worth that much. Does that work better? Oh. I'm trying not to snap the connectors back against the board like that. Alright, those are all out. Can we take these out too? Well, it's not anymore, yeah. Oh, okay, the IX5000 is some newer telepresence system. Interesting. Oh man, that must be how they get businesses to just pay that much. They're like, well, you're already hooked on this air travel stuff, and this might eventually be cheaper than air travel. Okay, this is still screwed onto the back panel in a bunch of places too. There are a bunch more of these little Allen bolts holding on. Each HDMI input has its own Allen bolt. This is great. And that's going... There's a little metal flange coming off the HDMI connector, and it's just threaded. And that's bolted directly to the case. It's beautiful. There's just so much going on in here. I guess I can probably undo all of these screws. Oh geez, I have to take the nuts out of the HD or the DVI ports also. Oh man, the DVI ports, each nut has its own lock washer. Oh my gosh, Ryan says that this is apparently still $1,200 on eBay. Wow. Are you serious? Maybe I can put it together in working order. Alright, I think... Can we remove the next board? I don't even know where the board-to-board connectors are for this one yet. Oh, and there's some screws I need to take out. I'm not quite sure how to get these two bottom boards apart from each other yet. This thing is such a mess. Like, it's fancy outside, but like servicing this thing seems like a terrible proposition. There's this little breakout board in front just for an infrared receiver and some LEDs. This is just such an awkwardly large piece of equipment. I wonder if I have to take the whole board out. Annoying power connector there. Alright, so we've got power connector and several fans. I'm gonna well, oh, is it just one? Oh, geez, really? The bottom board has all these little routed tabs. Oh, that's not a separate board. That's just a sticky out bit on the bottom board. All of these are. Who designs things like this? And then gets bought by Cisco. Oh, man. Oh yeah, good call. Electron Ash in YouTube chat says place your bets on the type of CPU / FPGAs, ARM, MIPS, Intel, or other. And they're betting on Marvel or Broadcom. Oh no, and then Emily is cheating and saying it's power quick. Ooh. Robert says to try removing the heatsink by rotating it. There might be screws underneath. I'll try that. I mean, it's like a bunch of separate little pads. So like, yeah, maybe I could get enough shear force in there. But I don't think. Yeah, let's try that. This thing is super annoying. I could also try to get in there with like a knife sideways and cut the thermal pads. But I was hoping not to damage the thermal pads. I think this is working. Finding an area of the board that's carefully free of passives. It's not getting me very far. Oh, I think it's working. It's coming up on this side. This side needs work. Most of these areas that would be free, though, have passive components that I don't want to damage. I also don't want to pull these BGAs right off the board. So I'm trying to be very gentle. You are still slightly stuck. Okay. Wow, that is some grody thermal glue. Whew. Oh my god, lots of TI silicon and Altera parts in here. Wow. We have 5 Cyclone 3 FPGAs. So there's the big old thermal block. Wow. So yeah, these, it looks like it looks like all of these little squares are RAM. So it's like all of those are RAM, all around here. These are all Marvel chips, which could be more RAM. So these are Marvel, these are Mechronics, more Mechronics, so much dust. And yeah, Altera, more little chips, which might be transceivers of some kind, or maybe more, just more RAM. Wow. And these look like the board-to-board connectors, now we're seeing them. A bunch of 0.1 inch headers up here labeled JTAG 1 through JTAG 3. And there's an unpopulated one labeled FPGA. And then a small one that could be I2C. Let's also get, I'm going to bring over some air duster can. It's kind of late, I don't really feel like firing up the air compressor, but I'll bring a can over. I think the camera was pointing at the shark hat. Delicious. Okay, Robert reports the TI parts are DSPs. Wow, so we've got a big parallel processor here. If we could program the TMS 320 and the Cyclone 3, we would actually have a great little node here with a bunch of analog inputs and outputs. Oh, and then here's a big old Marvel chip in the corner. What is that? Well, the electrons are going to fall out. Wow, there's just so much in here. What is that? 98DX? Anyone got a read on that? Oh, a switch. For what? Is this like PCI or Ethernet? Is this an onboard Ethernet switch? Oh yeah, just catching up on comments really quick. Oh, interesting. EP3C40, I forget what that was from, but then Emily on YouTube says, Googled it and a Cisco forum thread with boot up logs popped up where it has debug CPU info and so on. Wow. CPU E300C1? Oh, that's just like a hex code. MPC 8347. So MPC 8347 sounds like the system on chip we're talking about. 600 megahertz, 512 megs of RAM, and TMS 320 DSPs. Yeah, okay. Oh, here we go. And then Fred has a useful comment up here. The C60, EX90, etc. devices that run the TC series software are Linux-based. You can check this out if you look in the logs when logged in as root. Nice. Okay, Robert says it's definitely onboard Ethernet. The 88E1111 smaller Marvel parts are Ethernet PHYs. Whoa! Whoa! Wow! So this is broken up into 5 lanes. Oh my gosh, this is amazing. So we have 5 video processing lanes, each with their own FPGA. Let me restart the camera here too. So then each processing lane has an FPGA, 2 DSP chips, all this RAM, and 2 Ethernets. And then this is the Ethernet switch. So we have 5 of these independent processors that are each 1 FPGA and 2 DSPs and lots of RAM. And then all of that's combined together into this big old board. Yeah, Ryan says that would be the 5 simultaneous video streams. So yeah, I guess these are just all doing their own little H.264 thing. And yeah, as Electron Ash says, crazy money is no object build. Yeah, exactly. Man, I just don't know what to do with these though, because like it's, I mean, I guess the thing is put it on eBay, like if it still works, but man. Well, let's see if we can get this next board out. I'm curious to see the bottom layer. It looks like there's a lot of goodies over there too. These standoffs are kind of a problem. But let's see how far we get if we just take off these little standoffs. Emily says, also, does this still work or is it fried? I don't know. We didn't turn it on first. I've been acting as carefully as, I would to try to keep it working if it was working, but I don't actually know if it works. The camera seemed like it might have been having mechanical problems, but like we should totally take it apart and see what it's like. Oh wow, Robert says the Marvel Switch has its own CPU as well. Yeah, of course. Like its own microcontroller or its own like copy of Linux, or what are we talking about there? Oh, Chris says, that's good. If you put it back together and it doesn't work, you can just assume you got it fried and not even have to consider that you broke it. Yeah, exactly. So much DSP going on. Oh yeah, and then Hal suggests installing Linux, or getting a, root on it and then doing regular Linux stuff. It's all the visible screws. Oh no, it isn't. That's all the screws I could see, but of course I can't actually see screws. Yeah, it would be interesting to use this as an FPGA dev board, and that might not even require getting to know the rest of the system that carefully. The particular FPGA on here is so it's an Altera Cyclone 3 series, and the part number is EP3C12, or sorry, let me start over. EP3C120F780C7N. So I think the relevant part of that is EP3C120. EP3C is the Cyclone 3 series, and 120 I think is the size. I don't know what the sizes are off the top of my head for this series. So, okay, I think we're down to pulling this one off the board-to-board connectors now. Which is kind of tricky. Turned into a slow mining rig, right? I've got one of the connectors off now, and there's going to be some more on the right side. It's around... how do you service this machine? Taking off this bit of copper tape. It looks like I've got to pop all the board-to-boards off and then again slide the connectors out the same way I did with the RCAs at top. It's just, I can't get in there. Like, do I have to take the fans out first? Do I just have to have smaller fingers? It's acting like I forgot a screw in this area. Oh, one of the coaxes are still plugged in. That wouldn't cause this problem, but I should fix that. I don't know, man. .486 PC core? What? What? How did we get on this subject? It's still hanging somewhere around here. I don't even know if I have an anti-static bag big enough for this board. Oh, there are little sets of 4, what must be test points next to each FPGA also. This is frustrating. I really don't see anything else that should be holding this. I mean, maybe it is just the board-to-board connectors. It's acting like it's being held down right around here. I could try taking the whole thing apart, but I don't think that's how it's meant. I think this board is supposed to come out next. those connectors feel free on the back. JD mentioned the DVI connectors having screws. I thought I took those out. I took those out. There's still some in the bottom, but we're on the middle board currently. Sorry, that doesn't focus. But these I've taken out. It's acting like something's holding it down right in there. So let this come off. I could try taking off the front. I don't know if that would help. Why not? Need the little wrench. Fred says maybe they just both need to come out at the same time. Maybe. Just, I'm not sure how that would actually be implemented at this point. Oh, that's not Torx. That's just a smaller Allen key. M2. Another different kind of screw. But those are pretty obviously different. It's the first countersunk screw we've had. Slots at the bottom. I don't see what's holding in the board. I can see the perimeter all the way around. The perimeter is clear. It's not being held in by the perimeter. It was being held down by a bunch of nuts and posts, but I think I got all of those. And then there are board-to-board connectors, but they wouldn't supply that much hold-down force, and I think I've got all those too. I just took off those screws. And what does that do? I think that lets me take the side panels off. I don't think it's the only thing I need to do to take the side panels off. Oh, I think those plus the screws on the bottom take off the side panels. The screws on the bottom are different. The screws on the bottom are Torx. Different Torx? Are we back to T, whatever this one was? Yeah, okay. It's not a completely different Torx. It's one of the two Torx sizes. Oops. Oh, it looks like the front panel comes off here. Yeah, let's just take as much of the panel stuff off as we can, because I'm sure that'll help. It was a little tight getting the boards out with the fans in the way. I'm just taking like all the screws out of the bottom at this point. Chris is asking incredulously if the camera really cuts off the video and the lens is removed. Isn't that pretty standard for a DSLR? Yeah, this does have a mirror. The camera is a Canon Rebel T5i. It's a DSLR with the kit lens. Oh yeah, Tim, so in answering my question, my ask about like how is it even still hold on, Tim is asking or suggesting maybe it could be adhesive tape or SMT nut certs on the bottom. That's interesting. I hope it's not a nut because I don't know how you would get to those, but it certainly could be tape. It looks like the side panel wants to come off now. Oh, that is beautiful. How is that manufactured? I mean, I think it's a machined extrusion. I can see the machining marks, but I don't think the whole thing was machined. I don't know how they made, for example, the these are like countersunk screw inserts here. And so most of this seems like an extrusion, but then they have these little bosses that are stuck out from it. So that might have been a separate piece that they pressed on like a rivet and then machined out. That's super weird. Try to take the same approach on the left side. Oh yeah, Ryan says, damn, that's a fine extrusion. I agree. That is a very quality extrusion. Oh, Tim Williams says those are riv nuts, or whatever you want to call them, the things that are the attachable nuts onto the extrusion. Cool. Yeah. There we go, that's the other side. Oh, you can see this one has a little spot that they left unanodized so that the heatsink can make electrical contact right along there. It has a little wiper spring kind of thing. Oh, these are really nice. This is becoming a bit more practical with all the side and front panels off, and now it's just this bare board. There's one screw still holding the fan panel on. Okay, I think the fans will come off now. Yeah. They need to be unplugged, of course. All right, so this whole thing just, oh, this is really solid aluminum too. So we've got a light pipe for the front LEDs. Oh, these two fans have ferrite beads and these don't. I wonder what that's for. We have fans look pretty nice. This one's a little bit worn out actually. The bearing doesn't spin that smoothly. 12 volts. Put this one aside. This is pretty nice though. It has the logo plate and some stickers. And IPA. Ryan says those fans were closer to the Precious, the ones with the ferrite. All right. Does this illuminate our situation anymore? It at least gives me more camera angles to work with, which is nice. Speaking of Precious. Alright, well I can at least look and see what's going on now. What the... Oh my god. I was not expecting that. Okay, I was completely wrong about the board-to-board connector situation here. These are going up, and I must have... or no, where are those going? Those are for things that aren't installed, actually. Because this, okay, so this analog board, which is the only board we've taken off so far, believe it or not, we've been at it this long, and this is the only board I've gotten off. This one has this little 2mm mezzanine, which is cool. That's great. But then I was looking at these and thinking, oh, those go downward, and then I started pulling this off, and I felt like what I thought were these two coming off. But let me see if I can share this. I have to move the camera down a little. Okay. And lift this a little. And maybe bring a flashlight. So yeah, these are the board-to-board connectors I thought we were looking for, but they don't go anywhere. And you can see there's a lot more headers down there that go to debugging or options that we don't use or whatever. But right back there, you see that monster of a giant board-to-board connector. And then, oh, look at that. Another monster of a board-to-board connector way back there. So I think we're going the right direction. We just need more pulling and in the right locations. Oh yeah, as Ash points out, I could probably just read the FPGA config over those JTAG ports. I probably could. There's a lot of things I could read out of here. Yeah, I don't quite know what direction to take this project in, but if anyone out there has ideas for what I could do with this, or who I should send it to, or what I should turn it into, then let me know what you think I should do with it. Okay, so that one I think I've got out, which is why this started to feel better, but this one back here needs work. Oh, this is terrible. How do you do this? You need like one of those pizza oven removal tools. So it looks like if I had a way of attaching to this board right where these two holes are and pulling, that would be ideal. So I'm guessing they have a tool that does this when they service these things. Like, it would have to be something that has like a little flat hook so you can slide it into the hole and then hook it over the opposite edge and then pull. I don't know if I have anything like that. Fred says push a balloon in there and inflate it. That's interesting. That seems like a great electrostatic generator. Maybe an antistatic balloon. It also seems like maybe we would, well, no. Getting the bottom board off without taking the top board off would be very difficult, because I'd have to actually unscrew all these standoffs from way out here. Oh, that was it. That was not pretty, but it worked, I think. Oh. Maybe I'm framing this. I mean, that would be a waste of a good board, right? But it's so pretty. Wow. Okay. Wow. Let's just, I mean, wow. Let me carefully put this aside and then put this on my anti-static mat for a sec so we can take a look at it and so that I can grab an anti-static bag for it. Oh, and it looks like we lost there's a little tiny grounding finger that came off somewhere. I didn't quite see how that worked, but I'm guessing that was under one of these screws. We'll have to look for a place for that. This might be slightly less EMI compliant. Oh, nice. Electron Nash says HSMC or high-speed mezzanine connector. Oh, I'm bleeding on this. I mean, I'm bleeding. Did I bleed on this, or am I just bleeding on me? I don't see any blood on the circuit board. Let me wash off my hand. I don't quite know how that happened. Yeah, Chris says, oh, I'm bleeding. Me after every complicated electronic disassembly. Yeah. Oh, and Emily says, take and post a high-res scan or photo of the board. Yeah, that's a good idea. I should clean this dust off. I have a flatbed scanner. I think I could probably fit this in there in 2 passes, like scan the board in two passes. That would take me a little while to do, but I mean, I could just like post a photo on my phone to Twitter like right now. I can do that. Photo. This is not going to be very good, but then again, neither is Twitter compression. be careful with these mezzanine connectors. Oh, hey, oh, Tuco, careful. Tuco's exploring the box, and the box is covered with delicate aluminum extrusions. I have the robot, give the robot some help locating Tuc. I will post a quick tweet about this. I don't think the video quality is going to be terrible, but or the image quality. To go to such effort in Twitter to not capitalize Skype. Thanks, autocorrect. Okay, this is pretty cool. Man, I needed to show some of this under the microscope at least. So actually, yeah, you can see the copper dots. Someone was asking about a little earlier, up close. All the passives, all the vias. Wow, the vias. So many vias going on. These are the DSPs, on the backside at least. This is the backside of, what is that? That's the Ethernet transceiver. That's Ethernet, DSP, or no, sorry, that's Ethernet. What is that? That's like some power thing. So we have Ethernet, DSP, another DSP, and FPGA backside. Not a lot of components around here. We do have some of these. Is that memory? 88CY3K. Is this more bus transceiver stuff? Looks like there are 2 of these for each channel. They seem to be... I don't know. It's hard to tell what those are without looking them up. There's also this little one. TI PD9535. Seems to be some regulators. And then there's one more chip over here on the back. Let me swing the board around. Another Linear Tech 8850, I think. All right, well this is an important, I don't know if it's an important circuit board, but it's definitely impressive. Hey Tuc, where are you? All right, well, let us look at the final board here and finally see the system on chip. Well, system on chip. I think what I mean is the application processor. Wow, I am still bleeding actually, kind of a lot. Let me fix that. Sorry about the unscheduled fluid leakage break. I can't even tell you what I'm leaking because of. Could be any of those pieces of metal. Okay. So let's try to carefully put this aside. Oh, let me fix the chat, sorry. Okay. Is there room on the desk? Kind of. Sorta. Alright, yeah, we can do this. Oh man. I would like to see the back side of this board, which means undoing a few more screws. But what do we have so far? Oh man, this chip is monstrous. Freescale BGA over here. This is an MPC 8347, which some of you might already know if you were looking at the chat. It shows up in the boot logs, but wow. And then we have another Cyclone 3, just covered with Texas Instruments DSPs. So yeah, we have nine more DSP cores, each of which with a bunch of RAM, so 2 more RAMs for each. And then, are these more bus transceivers maybe? And then an Altera Max CPLD over here. Man, there's just so much stuff on here. More Ethernet for the actual external Ethernet ports this time. More RAM way over here. I don't know why the RAM is so far away. So then these two might be JTAG. Actually, yeah, I don't know. We've got a bunch of candidates here. So this is, yeah, actually that doesn't, these are 32 pin, these are 14 pin, or no, 32 pin? No, 16 pin, sorry. And that's a 14 pin. And that's 10 pin? Okay, so we've probably just got a bunch of stuff going on. These have more little TI chips next to them. KS257. And there's one of those next to here and next to there. Like, I'm guessing that might be a digital buffer of some sort. Wow. And then we've got this ST module over here. Oh wow, that's right next to a port labeled I2C debug. Oh, that's a real-time clock. It's a Snapchat. Is that actually socketed? I think it is. It's a snap hat, which made me think, oh, is it actually snapping? I think it actually might be a thing that snaps onto a socket. Yeah, and then I2C debug right next to the real-time clock. And you can see all these little routed things. Oh, and an Atmel processor. Is that running the fans and temperature management and stuff? That is an ATmega 644V. Oh, wow. So we also, on each of the boards, we have these little voltage breakouts. So this shows all the different power supply voltages. 1.2, 3.3, that say? Oh no, 1.2, 1.3, 1.5, 1.9, 2.5, 3.3, 3.3 standby, 5 volts, analog 5 volts, analog 15, analog minus 15, analog 48 for the microphones, I assume, and 12 volts. Okay, that's a good selection of power supplies. Oh yeah, and the video codecs and microphone amps for this layer are just like right here on the same board. So that's more video chips. What are these specifically? That's an NXP SAA 7129. I'm guessing that's for composite video. We've got some THS 8200 and AD 93898. What is running the USB? I don't see any chips next to the USB, so maybe that's on the system on chip. But it's hard to tell. And actually the other USB port was on the other board. This is just the host port. Anyway, let's take a brief look at the back of this board and at least take some photos. I probably should wrap up this stream soon, and I think it'll take, like, I want to actually scan these boards before I reassemble it, so maybe I'll just save the rest for a different stream. And we can take a look at the microscope. We can take a look at the camera that came with this and try turning on the codec and see if this thing actually works. See if it Linuxes the way it's supposed to. Oh, is the chat stuck again? Sorry about that. Tim Williams predicts new in Hackaday, Arduino video teleconferencing by scanlime. Yeah. Oh, and then CY233, according to Grant Char, is a Link Local Intelligent Network Controller. Whoa. So, man, this thing must have a pretty complicated onboard Ethernet. And that's going to be something that we can investigate pretty thoroughly from the Linux side if we can just SSH in. So this could be a fun platform to poke at even without a lot of really detailed hardware hacking. But if we do need to do the detailed hardware hacking, then it might be useful to have some kind of extension for this mezzanine because, wow, like debugging the two stacked boards must be a super pain. And they have all these connectors on the bottom board that are just going to get covered up when you stack the top board on. Oh yeah, Hal says the default username password's in the documentation. Nice. Yeah, I think I'll probably have to save that for the next stream, but let's do that. And I admit, I'm thinking like, well, the thing I would like to do is try to find the most minimal way of setting this up now. It's like you've got all this stuff that's going on, but would it boot, for example, with just the bottom board? Probably. It would probably even have video output. But maybe that's not the first thing to do. There's just so much going on in here. Oh no. Electron Ash says somebody just posted a video on Facebook which has the wonderful clickbait title of playing GTA 5 on an old Nokia phone. Nope, it was just an Arduino streaming video from the PC to the LCD. Yeah, that's been done so much. I mean, I feel like with every generation of new hackable widget, there's somebody being like, look, I made this generation of hackable widget run this generation's PC game thing, or some other generation's PC game thing, and it's like, cool story, bro. And like a lot of times what's going on there is that actually the underlying hack is kind of interesting, but then the way it gets reported just makes it seem different than it actually is, which acts as kind of clickbait for people who don't know what they're doing and just like disappoints people who are expecting a particular thing. So that's frustrating. I think I'm down to just back panel connectors now. Oh, nice. Emily says, the only game in a place it doesn't belong I liked was Doom running on a PC-based scope. Yeah, that is also a good name for that trope, the game in a place it doesn't belong trope. I'm also realizing that I guess I was guilty of doing that once or twice. I didn't even do it for real. I helped out with an April Fool's prank once, where we were developing this. Well, it was. I say we. I was mostly just the roommate / accomplice in this, but my roommate at the time was working on an open source video game called BZ Flag, which was like kind of a Battlezone inspired tank game. And he was like a contributor and hangs out in the IRC channel and whatever. And so he wanted to do an April Fool's prank. And so the two of us conspired together to make what looked like a GameCube port of the game. But it wasn't even really real. I mean, these days we probably would do like a GameCube port for an April Fool's prank and it still wouldn't be very useful. Oh man, I've got to undo the nut for the composite video output also. Why does this have a composite output? Oh, I just dropped a nut. There it is. Tuco is under the desk at my feet. I don't think the computer knows that. Oh yeah, there's a mention of making music with floppies on the chat. I've been listening to the Flopotron YouTube channel a bit lately. I think they released a new track or two, and so it kind of re-entered the list of videos I was flowing through. There's actually a bunch of... Ugh, the serial ports also have nuts I need to undo. This thing is really not designed to be easy to take apart. I mean, they could have made it worse, but they could have made it a lot easier. And the thing where it's designed so that you can only run it when the boards are all stacked is pretty annoying. Speaking of things that can only be run when the boards are all stacked, I was looking at the iPhone X Teardown that everyone was like aghast at, and I think the thing that a lot of people were surprised / horrified about was how they stacked the 3 circuit boards. And I'm looking at that and noticing the similarity with like protective metal grids on really security sensitive chips, and thinking, well, what if they... I mean, I think the actual answer is they use those vias for routing signals that they just would need to route anyway, but like how far would they go out of their way to just like route in an extremely convoluted way so that you like couldn't actually get into the center even if you were willing to patch the wires around? And I think actually what's going on is, well, they've got the same effect, it's just because the whole thing is routed through those vias anyway, that it would be a monumental patching job to actually get in there, but I'm sure people are working on it. Actually, the way you'd probably do it is make a flat flex that you can replace that center board in the iPhone with. So you'd unsandwich the 2 boards, then reattach a flat flex on both sides that would connect the 2. But signal integrity would be really hard. And there might be ways that Apple actually tries to detect that by doing signal integrity tests. I need an actual crescent wrench now. I'll be right back. Oh, can I cheat with this? Yes. That worked fine. Oh, I saw one of those headphone port mods. It seemed interesting. Okay. And DVI ports, and I think I still also need to get these RCAs. Keep these lock washers on. Tuco is exploring all over, and the camera has no idea where he is. That's cool. I could maybe help it out. Oh no. Windows is asking if I want to open the game bar. No, this isn't a game. It's just a cat. Oh, Tuco's in the box. I don't see any more. Oh no, there's the couple more. Not these. Those are the tiny torques again, maybe. Okay. Are these the last two? There are a lot of screws. So far, they've all been pretty obvious about where they actually go. Oh, the gimbal is unhappy. Oh yeah, that's loose. Oh, I forgot one side of the DVI port. Okay. Electron Ash says most of the 10-pin headers will probably be JTAG for the Cyclones. Yeah. But like, so here's a 10-pin header, for example. And there's a 10-pin. But then we've got these wider ones, like the 16s, and then this one might be power supply related. Yeah, a lot of debug headers. Okay. Can we has motherboard? We can has, oh man, this is, do I have to take the power supply out? I don't know if I can get this out around the power supply. What did they do with this design? Everything, I mean, I'm not the one to talk, because like, look at how hard the winches are to put together. Seems like a nice little power supply. What is the output voltage? Can we tell? Is it 12 volts? Those two go. Wow. Got little red glue dots on the bottom of there. Okay. Can we finally? All the XLR jacks want to get stuck on the back case. Okay. Let's move the metalwork out of the way, and then wow. And the back side. Oh yeah. So we got some more of those analog devices preamps. These are just like the same microphone preamp circuit, cut and pasted a bunch. Got all those beautiful vias below the big BGAs. That's the capacitor bank on the bottom of the system on chip. And then some more linear tech parts. Oh, these just seem to be local power, but I'm not quite sure why they're spaced out so much. This board is very roomy. Like this board, they didn't need to make this one so big. It was just, it kind of needed to be big because it was the one on the bottom. Oh, these big controlled impedance differential pairs, those should be USB. So that one is USB host, and oh, so there are, yeah, the one on the left is not controlled impedance, the one on the right is. So the USB host is going, oh, to the USB host chip, where everything tastes like USB hosts. Oh, there's a button for USB host. Oh, geez, there's LEDs and a button right over here. So I traced the USB over to this area, and then look what we find. It looks like that NXP chip on the left is the USB PHY, and so we have two of them because there are two USB ports, host and device. And I'm guessing they're both implemented in the Freescale chip there, given that we're right next to it. But then right there we have lights for USB host, lights for USB device, and a software reset button. Oh, that's so nice. Ah. Oh, Tuco's hanging out right here now. Yeah, it's gonna be fun to try to get this thing booting up. Is there anything else we need to see here? So just to look at the top board here, there's the system on chip. It's a massive BGA. And then I'm guessing that's flash memory. Actually, maybe these are both flash. This is Spansion, and that's Samsung. The Spansion might be, well, no, this is going to be system RAM down here. The Micron stuff. I don't know why they put the RAM so far away. My only thought is thermal. Another debug port. All these debug ports have one of these chips next to them, which I'm guessing is some kind of buffer. Glitch in the matrix. More Ethernet. Oh, so now we're getting into, what is this? So this is the external Ethernet. This is Ethernet. These are the Ethernet ports. They must have built-in magnetics. Is that an... Oh, that's a relay. This 12-volt DC relay. It must be for these external inputs. I'm guessing that's for like a contact closure input or output. The mic preamp circuit is the same thing we were seeing up there, these T1510s and AKM something or other. That's pretty nice, and fancy XLRs. Oh man, this thing is just so nice. Oh, that's a good guess. Robert says, my guess is that the expansion is a NOR flash boot ROM and the Samsung is a NAND flash for bulk storage. So yeah, that seems right. Oh, okay, and the AKMs are DACs and ADCs. Cool. Because yeah, they would want to be digitizing that as soon as possible, I assume. So, oh man, so this whole section would actually be a really nice digital microphone interface. And then these are GPIOs. It looks like all the GPIOs have their own individual polyfuses and then transistors. That's pretty cool. That's the USB host. The lines for that just went off on the other side. This, I think, is composite video output. So I think that's the composite codec. And then we have DVI and HDMI and DVI and HDMI. So I haven't looked at all those chips yet, but those are probably just like all the encoders for that. I don't know why there are so many though. And then those long flat ones are going to be more bus interfaces. So it looks like they probably just have some kind of shared high-speed parallel bus that all these chips piggyback on, and then the FPGA can just talk them all. But I would guess that means that we need the FPGA just to get any video output, like even during boot up. And then, okay, this is the centerpiece of the lower board. We have one Cyclone 3, 9 TMS320 DSPs, each with their own 2 RAM banks, and then 2 more RAM banks just for the FPGA. Or that might be a transceiver. That's definitely RAM. Oh, cool. Electron Ash says THS 8200 is a triple video DAC. Cool. There is just so much going on this board. I mean, the price tag is starting to make sense now that I see what's in this thing, because, geez, this thing must have been really expensive to build, and then really expensive to engineer. And now we can just play with it. Hopefully learn some things from it. Electron Ash says EPC-S chip above the FPGA. Don't quite know what you mean, but let's take a closer look. EPCS. I haven't really started looking for the bitstream because I figured the bitstream could be pretty much anywhere. Like any of these kind of thick small chips could be bitstream potentially, but I hadn't really been narrowing it down yet. I'm assuming that the bitstream isn't necessarily near the FPGA because, like, you have a product like this, you're going to bootstrap as much as possible from a single binary image. So I'm assuming the application processor bootloader starts up the FPGA bitstream and installs bitstreams out of the bulk flash from something, but yeah, I think Electron Ash and I just reached the same conclusion that the FPGA updates are probably installed by the software. Because there are so many processors on this board. Like, could we even count how many processors are on this particular circuit board? I mean, just the chips we've looked at, there are 11 processors. There are probably a lot more than that. What is that, HP? I'm guessing that's not Hewlett-Packard. Hey, Tuco. Well, I think this might be about a good wrap-up point. It's pretty late here, and my board is now covered with expensive electronics. and I think I might wait till I'm a little bit less tired to photograph and reassemble these. But I think everything is safe as it is. These are all sitting on my anti-static bench mat, and the other parts don't seem to be especially sensitive. Wow. And we haven't even looked into the camera yet. The camera should be pretty interesting inside. Look at all that. Hey, Tuco, you want to hang out, little guy? Oh, yeah, I gotta keep Tuco off of this. I might put an anti-static thing on top of it in case Tuco decides to walk across the whole thing. Yeah. Well, let me know if any of you have any last-minute questions as I'm wrapping this up, but I think that's a good amount of work here. We took it apart. It took longer than I expected to take apart, but we made it. There's also a little bit of PCB artwork over here that I was just noticing. Got a Saturn and an upside down, what does that say, P01400F1. So I don't know if that means something to somebody or if it's just the revision code for the board, but the Saturn is nice. Electron Ash is asking, is this the IX5000? No, the IX5000 was a much fancier one that we were talking about a little earlier, but this is the, what does this say? I think it was like a D90? C90. I can show you the back plate, actually. There you go, Tandberg Codec C90. That's what we've been inside pretty much this whole stream, but we also took a really brief look at this camera over here, which... So the codec might be fun to dig around in. The camera might actually be useful for Tuco Flyer, so that'll also be really fun to dig into soon. That is a nice pan-tilt zoom camera with what seems like pretty nice optics and everything. So, yeah, appreciate that a lot. Thanks for stopping by. Thanks for hanging out as we take this apart. And, oh geez, I keep having to look at the box just to make sure I don't flub up the name, but yes, Umar. Because I'm so bad at names, and I feel like sometimes I don't even really want to try saying people's name because I worry oh, I'll just get it wrong, and then it'll be worse than just not even knowing the person's name. But yes, that's just my own shit. Sorry about that. So yeah, thanks so much, Umar. This has been wonderful. It seems like I'll get some use out of at least a handful of those surface mount components, especially the capacitors seem super useful, and the inductors. And there's some really interesting chips in there we might find some projects for. And then we've got this thing, this just marvelous, weird pile of strange old electronics that still apparently would be pretty expensive. So, oh, that's interesting. Electron Ash says there's a Cisco Telepresence box on eBay at the moment for only 60 pounds shipped. Well, okay, well, so somebody else was saying that this thing was still going for thousands of dollars on eBay. If this thing is still worth a bunch of money, then I will try to maybe fix it up if it's having problems. But if it is basically junk at this point, then I might find some creative repurposing for it. But yeah, let me know what you think. If you're watching this later, then post in the YouTube comments. If you're watching on Twitch, send me a Twitch message. If you just want to tweet at me, then tweet at me. Then yeah, I mean, I'm usually pretty easy to reach on Twitter. Well, thanks so much for stopping by, and special thanks to everyone who supports the stream by sending stuff in, sending money via Patreon. That's what keeps this going as often as it does, is being able to do this pretty much full time. So I'm super grateful to everyone who supports the stream and supports the videos. I know we've been mostly streaming lately instead of doing edited videos, but I feel like with the milestone I got to on Tuco Flyer, I should start putting together production for a video about the computer vision and tracking, so that'll be in the schedule pretty soon. So yeah, I will see you all later. Thanks so much for stopping by, and I hope you enjoyed the cat tracking. Let's he is under there, and the computer can just barely see where he is. Oh, there it is. It updates every so often. Well, Thanks for stopping by, everyone. Happy hacking.